All right, so today we're learning about angles and congruence. And so I think the first thing is, in the vocab piece to talk about, hey, what's a ray? A ray is a part of a line. It has an end point or starting point. I like to call it a starting point, but it's called an end point, where the ray begins. And that's where kind of you've broken the line. And so you start here and you move off in a certain direction forever and ever and ever. And it includes infinitely many points that normally label one or more in on that direction. So to name it, you start with the end point, okay, and you put that on the left, and then you pick a point that's been labeled in the direction of which it's moving. So if it's moving, through N and O, in our case, you can pick either one. It doesn't matter which one, but pick one of the points in the direction of it moving forever, and you take that and you put a ray with an endpoint over the starting point and then an arrow going in, implying that it's going through N forever, and so forever and ever. So another option would be, hey, it starts at M and it goes to O and it keeps going in that direction forever. One thing that you wouldn't say would be OM, because it doesn't start at O and move through M, does it? Okay. And so you always put the arrow going to the right, or generally you do. So you put the endpoint there, even if the ray is moving diagonally up to the right or up to the left or whatever direction it is, you generally start with the endpoint on the left and then put the arrow on the right. So anyway, another bad choice would be NM. Okay. And so that would be a bad choice because it doesn't start at N, it starts before that. So you want to catch it at the beginning or at the end point where the ray actually starts. And so opposite rays. I did like a cool little dance move. It wasn't that cool in class to talk about, if you've got a beginning point, J, okay, and think about like a duel. Like, so the people who are in a duel, they start at the same spot and they march off in opposite directions, and then they turn around after a certain number of paces. Think about Alexander Hamilton. Okay, so if J is the starting point and each ray marches off in opposite directions, then you would have opposite row or opposite rays. And so, JK would be one of those rays as well as JH. And so we can name them, okay, and be like, oh, so what are the rays? So you start with J and you move towards K forever, okay? And then the other point, also the other ray that's opposite from there, moving opposite from J, would be to H. Again, even though it's going to the left, you really just put it starting at J and moving to the right towards K. And so we just kind of describe it verbally. We don't directionally speak if it's angling off other than someplace to the right. So it starts with J and moves through H forever. And so those guys are going to be opposite rays, and they're collinear. Notice they make a straight line. And so with that being said, we talked about in class to say, if you've got an open book, how many degrees are these pages of the book open to? And that's 180 degrees. It's a straight angle. And so, we know that all the way on a circle is 360. So halfway around a circle is 180. So that's something that we talked about today as well, to say, hey, a straight angle is going to be basically a book that's open, and so that the angle formed between the pages of the book is 180 degrees. And so I'm visually opening my hands up like pages of a book, but you can't see that because you're on a video. An angle is formed by two, and I forgot the word rays. Okay, so this should say rays right there. Okay, two rays that have a common endpoint. Rays. Okay, what do you mean, woman? Well, okay, so we've got a starting common endpoint of X, so X goes towards Y forever, and then also X goes towards Z forever. And when you put these two rays together, having a common endpoint at X, okay, it's called a vertex. You form an angle. And so this angle has it's like a mouth, it's open a certain amount. And so we can talk about this, we can name it. But I think when you name it, you've got to use three letters. How do you name it? Well, you start with a point on one of the rays, and then you do the vertex, and then you do a point on the other ray. So it'd be YXZ would be the angle. And so you say, okay, angle YXZ would be one way to name that. So you go kind of around it. The turning point must go in the middle. So the vertex or turning point has to go in the middle right there. Okay. And so if you did, this in a different order, then you would not have the exact same ray. And so I think that's important. Part two is to say, what else could you have? Well, you could do angle ZXY, okay? Or you could call it angle 2. And so if you're naming an angle, see right there that not all angles have like a number inside their the angle, but sometimes if they see that, that's kind of a shortcut way to name it. And again, sometimes they do, sometimes they don't. Sides, how do you form it? What are the sides of an angle? Well, the sides of an angle are the two rays that build it. They connect at that common vertex. And so one of the sides is going to be ray AD with a ray over it. The other one is going to be AC. We could call it AB, but again, the beginning point is that vertex, that where the two rays begin, and then they form the angle in that way. The vertex is going to be the common point and point between those two rays, so that would be point A. Okay, and then how do you describe the size of an angle? Now look at this, it's kind of weird, okay? I just got done telling you, you name an angle using 3 letters. And if you notice this one right here, it says measure of angle A. I only use 1. What's the deal with that? Well, if I am working with a student after school or before school, I'm like, hey, will you just do this? There's not an ambiguity as to who I'm talking to because there's only one person in the room. If there's a lot of people, if I'm like, hey, will you do that? It's kind of ambiguous as to who I'm speaking of or with. Now, in this first example, it says M angle A. It means the measure of angle A. Well, why didn't I use 3 letters? Well, because that's the only angle right there. It's pretty obvious that I can refer to it with its vertex. And so it's not the most common unless it's the only angle of the room. It's the only one you see. So if you look at the back of the worksheet, you see like lots of angles all around, running around screaming. But the thing is, if there's just one there, you can tell when I say measure of angle A, I mean the one above it. I mean the one that has a vertex of A. And so it is a shortcut, but it's something you gotta use wisely. And so the measure of angle A, notice that little box means 90 degrees is equal to 90. And you can write the word degrees or use the degree symbol. You do need to label your answers. If it's acute, the measure of angle B, notice I don't call it with 3 letters. Why? Because it's the only one right there. You can tell which one I'm talking about. So the measure of angle B is going to be between 0 and 90 degrees. Okay, so if it equals 90 degrees, it's going to be right. And then obtuse is between 90 and 180. And we should put our degree symbols on here because we're cute like that. All right, good. So again, the shortcut to writing the word degrees is to actually do that. So interior. Now, if I take out my hands and go flop, 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 like a little puppet, in an angle, the interior is inside it. So I asked her, like, what would you like to have for a little snickety snack right this second? And they're like, Jolly Rancher. And so if you're talking about inside of an angle, okay, that's going to be right here. Okay, oops, I didn't mean to do it that way. I wanted to highlight. Well, I guess I'll highlight now. This is the interior of the angle. It's inside the mouth of the angle, okay? And you can imagine like a point being inside of a Jolly Rancher. Say, oh, this is point J for Jolly Rancher. Okay, so point J. And so that's one location is the inside of the angle. Another thing to talk about would be on the angle. So you notice that you've got 3 points that are actually on the angle. Point A, point B, and point C are on the angle. Okay, and I missed a little bit here. So on this angle. So this would be on the angle itself. So interior in my little grid would be green. Okay, so inside the mouth of it. Okay, and then the exterior would be like outside. Okay, just like the exterior of your house is outside of it. So outside of the angle would be around here. So you can imagine there's so many points that could be out here in the exterior of an angle. And I think it's important to be able to talk about the vocabulary of inside or outside or interior and exterior, those kind of things. All right, let's move through to the next side. On the back, we got 2 concepts, and then we're going to kind of apply it. So congruent angles. Well, congruent means same shape and size, doesn't it? And so you can show that angles are congruent, by putting a similar number of rings on there. So like you could do a single little ring. You could do like Adidas socks. You're like, oh, they've got 2 stretch or 3. I don't know how many they have. You could match the number of stripes on an angle to say, hey, they go together. Or you can use the hatch mark thing to be like, ooh, I've got 2 angles and one has a single hatch mark on the angle. And, you can show that these match by putting 2 little hatch marks inside there or something. So there are ways to show that they're congruent. So I can put a matching number of rings here, like there's one on each side or there's two on each side, et cetera, to say that they're congruent. And then you could say angle, whatever is congruent to angle the other one. So congruent means same shape and size. So remember, congruent looks like this. Okay. An angle bisector, whenever I say the bisector, you should think, hey, something's chopped in half. Okay, whether it's a segment or an angle, somebody came in and chopped something in half, or your sandwich. Okay, so a bisector chops things in half. So an angle bisector means that's chopped the angle in half. And so it says in this figure, okay, so check out this figure, you will notice that this ray right here, YW, has chopped in half, okay, bisected or chopped in half this. And whenever things get bisected, they form two equivalent pieces, whether it's two segments that are equivalent or two angles that are the same measure. Look at this. It's got two angles, the same measure right here, okay? And so that red ray chopped that angle directly in half, sliced it in half. And so if we go through and we say, okay, let's start naming things, we can name all the angles right here that have are going to have B as a vertex. So let's start naming them. Okay, so one of them could be named angle GBA. Remember, if B is the vertex, it's going to be in the middle. So GBA goes here, GBA. Okay, so that's going to be right here. Okay, another one would be EBG. Okay, another shortcut name for that would be angle 5. See it over here? Angle 5. Okay, and so what's another one that has a vertex of B? B is the turning point, or where the vertex is where the angle, the two rays meet, where the angle turns. Okay, and so you're like, okay, angle 6 could be angle EBD. So you could call it angle 6 as well. And then the last one would be ABD. Okay, angle ABD, and then a shortcut would be angle 7. So sometimes they have a nickname. If you see an angle stuck right in that inside of that angle, you can call it by that as a shortcut. So name the sides of angle 5. Okay, so looking at angle 5 is over here. The sides are two rays, so you've got BG. So ray BG is one of the sides of it. Another one would be BE or BF. You could call it either one. So the starting point of each ray would be BG, and BE or BF would be the rays that form it. Those are the sides of it. What's another name for angle 6? Well, angle 6 is right here, okay? And so it could be angle EBD. Okay, you do FBD. That'd be another option. Okay, so as long as you turn a corner at that vertex, you're going to be good. So B would be the vertex of angle 6. So EBD or FBD. Yes, you could go the other way around the circle. That's fine too. Name a point on the exterior of ABD and then one that's on the interior. So what do you mean, Lemon? Well, remember, on the interior of your mouth, if you're like, oh, I'm going to have a snack. Well, you put something in your mouth to munch it. Okay, people mentioned Jolly Ranchers. So on the interior of ABD is right here. Okay, so if that's your little mouth, you're like, you can womp your hand around a little bit. The thing is that, there is no point there. So it says, give me a point that's interior of it. So angle 7 could be like angle J for Jolly Rancher. Okay, so inside there could be angle J. Where would be the exterior of that graph? Well, on that angle would be A, B, and D. Those are points that are on the angle. Exterior of the angle would be basically all around this exterior of the shape. And so some points that would be on the exterior would be point G and E and F. Those would be all good points that would be on the exterior. Okay. Name things as acute or right or obtuse. If you look at these and you're like, okay, angle MJK. Remember, J is where you turn a point. So MJ, oh dear, I need a marker. So MJ and then K goes right here. That's right. Okay. LJP, okay, is going to be right here. L, J is where you turn the corner, and then P. Well, that's obtuse. Okay, and then MJN, let's grab another color. MJN, so MJN JN goes right here, so that's going to be acute. Okay, so look at that. And I think the bottom three questions, honestly, in these angles, they may say, hey, oh, they're congruent. So you set the two angles equal to each other. They may say the sum of the parts is equal to the whole. Kind of depends on what you're doing with these questions. And so in this first question, they give you the ADC, okay, which is this whole big piece right here, is going to be equal to 115 degrees. And they tell you each part of 3x plus 12. And then they tell you that this part is 4x minus 2. And they're like, okay, what do you do? How can you find x and how can you? Well, sometimes if you know these are congruent, you can set them equal. Okay, so say that they've been bisected, you could set them equal. Well, in this case, we don't know that they're congruent, but we do know that the sum of the parts is equal to the whole. So the truth is, if you add this part plus this part here, you should get this overall big part. And so that's what we're going to do here. We can take our 3x plus 12 and add it to 4x minus 2 and set equal to 115, combine like terms to get yourself a 7x plus 10. Minus 10 from both sides. I'm running out of space. You get 7x is equal to 105 divided by 7. You get x is equal to 15. And that's what they're looking for. Now, if you actually want to find a value, you might have to plug it into this part of 4 times x minus 2 or 3 times x plus 12 to get your actual angle. Okay. And that's what they actually have you do in the next question, where you're like, just give me a second. All right. So the last two questions, the first one, if you look at, there's a lot of words. And so I think, when you start looking at them, sometimes it's a bit intimidating. So I would say, so Z is the interior. Okay. So you've got to point this on the interior of an angle. Okay. This is the angle we've got. And so if we draw the angle, we don't know if it's acute or obtuse, so you can pick one and go with it. And if you want to edit your drawing, just to be fun, you may. But you can draw yourself an angle and you can label it according to what you hear. Okay. It tells you that the angle is WXY. So since X is in the middle, that X is the vertex. Okay. The turning point of it. So it's WX and then Y. And then it says the measure. The M means measure. If the measure of WXY is 5x minus 58. So WXY is the entire angle. So sometimes it's nice to highlight that and say, okay, so I'll pick a color and here we go. So the entire angle is going to be 5x minus 58. So 5x minus 58. And then they say, okay, draw Z to be the interior. So Z is on the interior, and then we're going to draw this angle through here, or the ray through there. And so the ray breaks up the angle. And the question is, does it bisect it or does it just break it up? And if you read the words, it says, hey, it breaks up the angle. And so we've got the measure of angle YXZ. Okay, so YXZ, you got to read it in order. And so YXZ is going to be down here, is going to be X plus 1. And then also the measure of WXZ. So WXZ is 2x. So that's right here. And so the question is, are they congruent? No, because it's not bisected. So then we think, okay, what else do we know? Well, we know the sum of the parts equals the whole. So if you add these two angles below together, you're going to get the entire angle. So you got this, which is 2x, and you got down here, which is x plus 1. So if you add this part plus this part right here, you're going to get the overall piece right here. So we will add up 2x plus the x plus 1, and we're going to get 5x minus 58. Combine like terms, you get 3x plus 1 is equal to 5x minus 58. Let's minus 3x from both sides to get the x terms to the same side. You get 1 is equal to 2x minus 58. If you add 58 to both sides to get x alone, you're going to get 59 on the left. So 59 is equal to 2x divided by 2. And you're going to get a lovely decimal, which is fine. It's 29.5. So that's the value of x. It's not actually an angle, so you don't measure it with a degree. However, it says, what is the measure of YXZ? So YXZ is going to be this middle value, this middle angle right here. And so if you do if you want to find that, the measure of this is also equal to x plus 1. And so if you add x, which is this value, and you add 1 to it, you're going to get 30.5, and that's degrees. So that will be the measure of this angle, 30.5 degrees. So, it's not a whole lot new. It's just instead of working with segments, you're working with angles. The bottom one, okay, if you label all the things that we know the measure of AEB is going to be 6x plus 1. And we know that the measure, that's what the M means, is CED is going to be x plus 9. Says, okay, find the measure of DEB. Okay, DEB. And this is going to be DEB. It's going to be this part right here. Well, we don't know this part up here yet, unless we read, which we can. Okay, so what you do is you read and says, EA and ED are opposite ways. So it's kind of like this is their vertex, and then they walk this way, and this one walks this way. So they're opposite rays. But it also says that EB bisects AEC. What do you mean, woman? Well, if you do AEC, that's this right here. Bisects means chops in half. So think about your ninja. Okay. If you've ever broken a board in half, you know that when you splice it, it breaks it into 2 congruent pieces, maybe. Okay. But when we bisect an angle or a segment, it chops it into 2 congruent pieces. So what they tell you is that BE is a chopper, and it chops this overall angle into 2 congruent pieces because it bisects the angle. And so when this segment bisects this angle right here, you're going to get not only is this 6x plus 1, but also so is this 6x plus 1. And so therefore, the parts. Now, the problem, though, is still, do you set them equal? Do you add them up? If so, is there some equal to? And the answer is, guess what? You know what this is, don't you? Okay. This overall angle here is a straight angle. It's like an open book. Okay. So an angle, remember, entire around a circle is going to be 180 degrees or 360 degrees. So the half of a circle is 180. And so this angle here is 180. So if you add up these parts, these 3 parts right here, if you take 6x plus 1 to 6x plus 1 to x plus 9, you're going to equal 180. Okay, so add up like terms. 6 and 6 is 12. 13x plus 9, 11 equals 180. Okay, so you minus 11 from both sides. And you're going to get 13x is equal to 169 divided by 13. You're going to get x equals 13. Now, that's not our final answer, but that's a good start. And then they want us to find the measure of DEB, okay, DEB. So that's this part right here. Well, to find DEB, DEB is going to equal, both of these pieces together. Okay, so you take 6x plus 1 and then x plus 9. And so you get 7x plus 10. So 7 times 13, and then you add 10 is going to give us 101. And that would be a degree, because once you find x and you say, okay, that's the actual measurement of this angle is this. So on your homework, if you look at it, there's going to be some questions where that their review is with distance and midpoint. And I would say use your notes. Remember, in distance, you subtract or use the distance formula, depending if it's a slanted distance or a horizontal or vertical. And then also for the midpoint, remember, you add up the 2 x's and divide by 2, you add up the 2 y's, divide by 2, etc. And then thirdly, make sure that if things are congruent, you can set them equal. Sometimes you just add the parts up and that equals the whole. But yes, you've got a lot of steps that you can take to practice, and we'll talk about this on Friday. You are welcome to come in on block day before or after school if you'd like to as well.